Hey guys, Mr. McKinney here, just going through some applications of differential equations. So basically, these are some of the ways that you'll see differential equations presented on the AP exam and some of the different types of questions that have showed up a lot in recent years. So first of all, differential equations are just equations that have a derivative in them. And remember that the derivative is just the rate. So these are equations that start out with the rate. So the derivative is your rate of change. So rate of change, those are pretty much interchangeable. Now, if we go back to first semester, a function would be increasing or decreasing when the derivative, the first derivative, is positive or negative. And we can take that one step further and say that the first derivative is increasing or decreasing when the derivative of the derivative, or the second derivative, is positive or negative. Now, a lot of times the AP exam will ask questions about rates, not about derivatives. So another way to think about this is that the rate, the first derivative means rate, is increasing or decreasing when the rate of the rate is either positive or negative. So if a question asks you to determine if a rate is increasing or decreasing, you must look at the rate of the rate, or the second derivative. And if we start with the first derivative, that just means you're going to have to do the derivative once. So let's take a look at a former AP question. So this is part D of a longer question, but we don't need A, B, or C to answer this part. So it says a different procedure, and don't copy all this down. You'll copy down what's on the next slide. A different procedure is used to administer medication to a second patient. The amount in milligrams of the medication in the second patient at a time t is modeled by a function y equals b of t. So we're saying that y and b are the same thing, and that's the amount of medication. This function satisfies the differential equation dy dt equals 3 minus y over t plus 2. So this is my differential equation. At time t equals 1 hour, there are 2.5 milligrams of the medication in the second patient. Is the rate of change in the second patient increasing or decreasing at time t equals 1? And then we have to give a reason for our answer. Now, I don't want you guys to copy this whole thing down. What I want you guys to copy down is the simplified version of this problem. So given that dy dt is 3 minus y over t plus 2, and y of 1 is equal to 2.5. That's what this part is telling you. Determine if dy dt is increasing or decreasing. So determine if the rate is increasing or decreasing. So we're going to need to look at the rate of the rate, which is the second derivative, or in this case, d squared y over dt squared, second derivative. Okay, so I want to go from the first derivative to the second derivative, and then I want to look at whether that's positive or negative to figure out if my rate, my first derivative, is increasing or decreasing. So if I start with this equation, and then I take the derivative, in this case with respect to t. So the derivative of dy dt with respect to t would be the second derivative of y with respect to t. The derivative of a constant goes away. And then to find the derivative of this part, I'm going to need to use the quotient rule. Now I'm going to go ahead and move the negative up to the top. Some of you guys are going to want to leave it out front. It's up to you. You can either put it out front or leave it out front and multiply it in at the end. So I'm going to say plus, and now I've got to do the quotient rule. So remember v squared on the bottom, v times u prime on the top, minus u times v prime. So here's my u on top and my v on the bottom. So here we go. On the bottom, v squared, t plus 2 squared, and I put that on the top first. Now I need to multiply by u prime. So if u is negative y, the derivative of negative y with respect to t is going to be negative dy dt. And then minus, now I'm going to do u, which was negative y, times v prime. So the derivative of t plus 2 with respect to t, the derivative of t with respect to t, dt dt, is just 1, and the 2 goes away. So the derivative of t plus 2 with respect to t is just 1. So we've got our equation for the second derivative. We just need to figure out if this is positive or negative. And we've got our point right here because our t value is equal to 1 and our y value is equal to 2.5. Now this was on the non-calculator portion of the AP exam, so we're going to have to practice simplifying without a calculator. So 0 goes away, and I'm going to start plugging things in. So 1 plus 2 times negative, and then I got to plug in my equation for dy dt. So I go back to that original equation, which was 3 minus, I'm going to write it back over here, 3 minus y over t plus 2. So 3 minus, I'm going to go ahead and plug things in right now, 2.5 over 1 plus 2. So this is my negative dy dt. This is basically just plus y, so plus 2.5 divided by 1 plus 2 squared. I just need to figure out if this is positive or negative. So let's keep simplifying. 1 plus 2 is 3. I'm going to go ahead and distribute this negative, so I'd get times negative 3 and then plus 2.5 over 3. And you'll see why I left it like this in a second. Plus 2.5 over 3 squared. So I'm going to go ahead and distribute this 3 on top because when I do, it's going to cancel this 3 out. So 3 times negative 3, negative 9. 3 times 2.5 divided by 3, those 3's cancel out. I get 2.5 plus 2.5 over 9. So negative 9 plus 5 over 9, which would be negative 4/9. The important part is that it's negative. So then to answer this question, we would say that the rate is decreasing at t equals 1 because the rate of the rate is negative. And we'll practice justifying as we get a little bit closer to the AP exam. All right, I don't want to rush through the second example, so we're going to go ahead and cut this one off here, and then we'll start a new video for the second example. Hope this was helpful. Have a great day.